We'll proceed in summation to integral discussion. Okay, so long discussion is going on that how to convert summation in one dimension, summation in two dimensions. That is very big thing. How we can convert summation, how we can convert summation into integration. Okay, one is one dimension, one is two dimension. In the past video, we were calculating the surface area of a sphere, and in while calculating the surface area of the sphere, then we came to a point that surface area of a sphere is nothing but I am cutting a sphere, I am cutting a sphere into kind of n different part along x-axis and n different part along y-axis. And then what I'm talking now. Okay, I have a sphere. This is lightweight. This is not heavy, and it is really a sphere. Okay, this is different one what I used to take. So this is a sphere. If this is a sphere, then what is the surface area of the sphere? This sphere is centered at the origin. Okay, if I say that this is x-axis, if I say this is x-axis, okay, and I say this is y-axis, x-axis, y-axis, z-axis. This point is origin. Okay, this is xy plane, this is xz plane, and this is yz plane. Arbitrarily, if I move like this, arbitrarily, okay, along z axis, then this is z and xy plane. Okay, xy, I can say xy as xy plane. There is a axis called x-axis. There is an axis called y-axis. There can be one axis called xy plane axis. So if I say like this, then I'm rotating this in x plane axis. If this is x axis, this is z axis, then it is rotating in xz plane, z axis and x axis plane. If I'm rotating like this, it is rotating in z axis and xy plane axis. Okay, in that plane. If I'm rotating like this, then I'm rotating in z axis, y axis plane, z-axis, x-axis plane, z-axis, xy plane axis plane. Okay, this way we are rotating. Okay, if we are doing like this, and this, if this point is origin and this is x-axis, this is y-axis, Mr. Sphere is centered at the origin. The center of this sphere, the center of this sphere is at the origin. If this is the origin and center is inside this sphere, they coincide with each other. Okay. Now in that fashion, half of the sphere is above xy plane, half of the sphere is below xy plane. I take any point P here, any point P, and then I draw a line passing through P and passing through South Pole and then North Pole, and it is coming back to P. I make sure that Y is constant when I draw this line. Similarly, at point P, I draw another line like this. I make sure that X is constant here. Okay, can I draw hypothetical where neither X or nor Y is constant? You can draw. Who is stopping you? But this is how it is. So if this is point P and I draw a line like this, round line, I make sure that y is constant at any particular y. Typically, I draw at y equal to 0, x-axis only. At this point, if I draw like this, at this point I draw like this, then x is constant. Okay, I can take y-axis where x equal to 0. Now we have two circles. We have two circles. This is what we have demonstrated. We have two circles. This circle is where point P is here, and this circle is where y is constant. And now, if I see same point P, same point, I can say like this or like this, same point P. Now here, I draw a circle where x is constant. Now if I take this circle, I divide the circumference of the circle in n parts. And that n part, if I draw on x-axis, it will chop into n part. I believe it will chop into n by 2 part, because the bottom part will go and map there only. Means this will, from here to here, there will be n by 2 part, whatever it is. Okay, if I chop this circumference into n part, then on x-axis, this axis, if I map all the parts, then it will be form a chopped part on x-axis. Makes sense? Chopped part on x-axis. If I take this x-axis, there are chopped part. Okay, now it goes from 0 to n. I mean, chopped into to n part, then it will be 0 to n, I believe so, whatever it is. It goes from 0 to n. Each part width is not constant. How you can say it is not constant? Each part width is not constant. If I cut this x-axis from here to here, if this is the origin, this is minus a, that is the radius of the sphere. If this is the origin, then this is plus a, that is radius of the sphere. Okay, if I chop this into n part from minus a to a, means 2a length, if I chop into n part, one part length is 2a by n. That is same. But if I chop in circular fashion, then here the chopped part, this is same. Everywhere this length is same. This section, if I draw here, that will be larger section. If this section I draw here, it will be a smaller section. All delta x, if I name it as delta x, all delta x will not be the same. Okay, if I take ith section of the chop, this is the ith section of the chop. Ith section will go map on the x-axis. This x delta xi will be different for different sections. Anyway, what we have seen here is the length of this ith section is, if this is the x and this is another x, then this is delta x. If this is y and this is another y, then this is delta y. For the ith section, it is delta xi and delta yi. Okay, in that fashion, if I take the ith section, this is delta x, this is delta y. If I square delta x and square delta x square plus delta y square is the hypotenuse. That is the arc. If angle is very small, I can take arc as a straight line. This is the approximation we are doing. So ith section, the arc length is delta x for the ith section whole square plus delta y for the ith section whole square root is this length. Similarly, for this circle, if I take jth section, the length of, I'm sorry, I'm really sorry. I'm really sorry. This circle, this is x-axis, this is z-axis. When we took the sphere, then this is x-axis, this is z-axis, this is y-axis. So the ith section, the length of this arc is delta xi whole square plus delta zi whole square root. Similarly, for this circle, the jth section, the length of this section is delta yj whole square plus delta zj whole square root. Okay, in that fashion, at any point P, in that fashion, at any point P, if I have this length, ith section length as delta xi whole square plus delta z whole square root, and this side, this is xz plane, this is yz plane. This side, it is delta yj whole square plus delta zj whole square root. If I multiply these two lines, it gives the small surface area at point P. Okay, this is how we proceeded. Idea is not to repeat the same thing, but this is how it is. Okay, what is the length now? What is the length now? It is delta xi whole square plus delta yi whole square root. This is the length of the ith section in xz plane. Delta yj whole square plus delta zj whole square root. That is the length in yz plane. If I multiply these two lengths, then I get an area at point P. At point P, to get the area, this length and this length, if I multiply, then I get the area at point P. Okay, that area at point P now is square root of delta, because they are in perpendicular plane. I won't say these two lines are perpendicular to each other. I won't say in that fashion. But these lines are in perpendicular plane. That is for sure. One it is in xz plane and one it is in yz plane, in perpendicular plane. Okay, if that is the fashion, then the square root of delta xi whole square plus delta zi whole square into the square, this is pseudo code, this is not the actual code. Square root of delta yj whole square plus delta zj whole square will give the area, momentary area. Okay, how many area I expect on this surface? Okay, then x-axis I chopped and y-axis I chopped. Okay, then now I can say the number of area I expect. So all if I, this is the area, one area. Like that, if I add all the areas, then I get the net area of the surface. I believe this is all right. Okay, someone can consider in this fashion that x-axis I chopped like this and y-axis I chopped like this. In that fashion, we get so many areas. Simple. If I'm trying to calculate surface area of this, then x-axis, this is x-axis, this is y-axis, this is z-axis. Now x-axis, I chopped like this, and y-axis, I chopped like this. Whatever the section come, that is the section. If x-axis, I chopped n part, y-axis, I chopped n part, I have n square areas now that I can see. So anyway, the ith and jth in I section, in x section, the ith portion, and in jth section, the in y axis, jth portion, the area what we are talking at any point P, the area what we are talking at any point P is summation I equal to 1 to n, summation j equal to 1 to n, and then ith jth section area. What is jth section? That is the square root of delta xi whole square plus delta zi whole square into square root of delta yj whole square plus delta zj whole square. This is the area of ith jth section. If I add for all I and j, I get the full surface area. Okay, thank you very much. But isn't it look like the delta x I whole square plus delta z I whole square root? This is magnitude of a vector. What magnitude you are talking? Yes, there is a vector called delta x ith section I vector plus delta z ith section k vector. If I calculate magnitude of this vector, it will come exactly delta x I whole square per delta z I whole square. Okay, we can rewrite now. Now we have now magnitude of delta x I vector plus delta z I is subscript k vector, magnitude into magnitude of delta yj jth section j vector plus delta z jth section k vector. Both it will come to this location. Anyway, now it will again, if I, there are two magnitude, I can place inside one magnitude. Now magnitude and then one is, now this is a vector now. Vector now. Now we have delta I vector plus delta z I k vector, one vector, multiplied by delta delta yj j vector plus delta z k vector. Two vector multiplication is invalid. Either it has to be dot product or cross product. Since we are talking about area, it will be cross product. Now we have delta x I vector plus delta z k vector, cross product delta yj j vector plus delta z k, delta z j section k vector. Okay, cross product of these two vector and then net magnitude. Cross product of these two vector if I see, okay, then it is all right. What is first one? Delta, and then here sigma I equal to 1 to n, j equal to 1 to n. Now if I see these two, vectors, cross product, first vector is delta xi plus delta z k. Okay, I am leaving the ith section or jth section. If I take out delta x from here, first one, it becomes I plus delta z by delta x k vector. I can introduce here delta y by delta x j vector. Delta x outside and in bracket I plus, earlier it was delta xi plus delta zk. I took out delta x. Now it becomes I plus delta y by delta xj, where I introduce delta y by delta x because I know y is constant for this circle. There are two circles. One circle is like this, another circle is like this. I know y is constant. I can bring in delta y by delta x because with variation of delta x, delta y will be 0. So delta y by delta x will be 0. No problem, I can introduce now. 0 I can submit. So I plus delta y by delta x of the ith section j plus delta z by delta x k. Outside delta x we have. Similar to other vector, I can take out delta y and it will become delta x by delta y. Delta x I have introduced knowing that x is not changing here. In this circle, x is not changing. So delta x by delta y I plus j plus delta z by delta y k. Now delta x and delta y came out. Now we have magnitude of I plus delta y by delta x j plus delta z by delta x k, one vector. Cross product delta x by delta y I plus delta plus j plus delta z by delta y, delta x by delta y I plus j plus delta z by delta y k. Okay, magnitude outside delta x delta y is there, where delta x belongs to ith section and delta y belongs to jth section. This is multivariate summation. We are summing into multivariate case. The next expression now is that we have summation I equal to 1 to n, summation j equal to 1 to n, and then we have magnitude of two vector, cross product of two vector. First vector is I plus delta y by delta x j for the ith section plus delta z by delta x k for the ith section. This vector cross product. Another vector. Another vector is I plus another vector is delta x by delta y jth section I vector plus j vector plus delta z by delta z by delta x jth section. I'll restart the second vector. Delta y, delta x by delta y jth section, delta x by delta y I vector for jth section plus j vector plus delta z by delta y k vector for the jth section. Two vector magnitude delta xi delta yj. This full summation I equal to 1 to n, j equal to 1 to n. This is called repeated summation in multivariate case. This is something that is mind-blowing, amazing. Okay, in repeated summation in multivariate case, what is the solution? There is only one integration. If I want to convert into integration, then it is similar. Okay, if I want to convert into integration, it is very much similar that this is xy plane, this is x axis, this is y axis, this is z axis. The blue color here is the origin. Now, I have divided this x axis into n different chop and y axis into n different chop. If I have done like that, n different chop, then it forms so many area. If I cut x axis into different section, it makes so many linear chops. If I cut y axis into so many section, then it makes many linear chop. But if I combine together as an area, there are so many delta x, delta y, delta x into delta y, so many area I can see. Okay, in so many area what I am seeing here, one any ith section area is delta xi into delta yj. Considering y axis any jth section I am talking, in x-axis any ith section I am talking, that the section I am talking here is delta xi and delta yj. This is what there it is. Summation of I equal to 1 to n, summation of j equal to 1 to n, and their magnitude of two vector cross product. First vector is I plus delta y by delta x j vector of the ith section plus delta z by delta x k vector of the ith section cross product, and another is delta x by delta y I vector jth section, understandable, plus j plus delta z by delta y k vector of the jth section magnitude, and then delta xi delta yj. This is what we are talking, any ith jth section delta x y. Okay, how to convert into integral calculus? As I have always said, that integral calculus converting with integration means fx dx, limit x is from to where to where. It calculates the area. If someone mess up with this kind of thing, then triple dimension fold, and then he will lose his life. Integration always work in single dimension only. This is double dimension, single dimension only. Fx dx. If this is x-axis, this is a function over x-axis called fx, that is the height. Then fx dx will give the area underneath it. That's it, is the integral calculus. Calculating multiplication by calculating the area, that is the basic of integration. Okay, now how I can convert it into integral calculus? That is the scenario. Anyway, that is the first thing. Then we saw that the first section, that is magnitude cross product of two vector. It will transform into function over x and y only. Okay, let's consider xy plane as a single axis called xy axis, and this is z axis. Now there are two axes only. One is xy plane axis and one is z axis. Now if I see the first magnitude, it is function over xy plane. So I can write function over xy, and another is delta xi delta yj. I can write it as delta xy. Okay, now we have come to a function called function over xy into delta xy. This left side summation, there are too many summations. Okay, leave it. It can be n into n square. I can say now that I have a summation that is I equal to 1 to n square, or j equal to 1 to n square, or k equal to 1 to n square. Summation k equal to 1 to n square f of xy plane of the kth section delta xy of the kth section. I made it no single dimension. Now this is xy plane axis, rather than saying x axis xy plane axis, and this is function over xy plane axis. There is a function line, continuous line going on. This is what is the cross product of two vector and its magnitude. If I calculate an area underneath it, then that is fxy plane d of xy plane, because xy plane I have taken as axis. Now in that fashion, it will be area under fxy with the xy axis. But this area what we are getting with the xy axis, I can make it chop into different subsections and add all the sectional area. It will become fx dx1. This is what it is now. Summation of k equal to 1 to n square function over xy plane of the kth section delta xy of the kth section means if this is xy plane axis and this is origin, I cut into n square chop, and this is the kth chop. In kth chop, if this is the function over xy plane and this is the delta xy kth, if I multiply this width with the height, I get the kth area. Like that, if I add all the area, I get fxy dxy. This is what is there. Summation of I equal to 1 to n square function over xy. This is the repeated summation for the multivariate case. Function over xy plane axis at kth section delta xy at the kth section. This is the area of the kth strip. If I add all the strip area, it will give the full area. Now this is a fit case to convert into single. There is one integration called single integration. There is no double triple integration. Now we have integration sign limit of xy axis from begin to end. F of xy plane, d of xy plane. Okay, f of function over xy plane I know, magnitude and cross product of two vectors. D of xy plane where x and y are vertical to each other, orthogonal to each other, it can be rewritten as dx dy. More or less, this is what the integral form is. Anyway, the bigger thing I want to say that delta x, what we are taking, all delta x are not of the same width. They are of different width. All delta y I am taking, they are not of the same width because I did not chop it in equal partitioning along x-axis. The real angle, the real thing that I chopped is this circle. That if I took the point P, if I took the point P here, then first I draw a line like this in the keeping y constant, and then that line is the circle where I have kept y as constant, and I chopped into n part, where each part if I map on x-axis, the chopped width will not be the same. Can I integrate certain? I can integrate. If I am saying that I have summation of k equal to 1 to n square function over xy plane and delta xy of the kth section, all the kth section, all the section in xy plane may not be the same. But what I believe it is very intricate. This is intricate. Intricate in a sense, if this is x-axis, I'm sorry, this is xy plane axis, and this is the vertical is the function over xy plane. This is xy plane axis, and this is function over xy plane. In that sense, I cut into n square part where each part is not same. The width of each part is not same. I cannot say that I cut into n square where, because we saw that each part is not same. If I talk about the kth section, then the width of this is delta xy of the kth section. If I multiply with the function over xy, it gives the kth section area. This kth section area, if this is the first, this is consider this is origin. First section, second section, third section, kth section, n squared section. All section area are not same, but they are non-overlapping, and if I add all of them, it gives the full fxy dxy area. No problem. It may not be, all area may not be the same, not required. Okay, in that fashion, we can convert it to integral calculus, and we have seen that 4 pi a square is the, if I had taken in Cartesian coordinate system, then xy lies on the upper half of the hemisphere. I have to multiply it with the 2 to get the final spherical surface. Okay, we started a discussion in the polar coordinate system. Polar coordinate system has three coordinate systems. All three are orthogonal to each other. How it is orthogonal to each other? Okay, I know Cartesian coordinate system, everything is orthogonal to each other. Cartesian coordinate system, everything is orthogonal to each other. Okay, in that fashion, this is x-axis, this is y-axis, this is z-axis. All are at 90 degree. All are at 90 degree. X and y 90 degree, x and z 90 degree, y and z at 90 degree. Similarly, if I take a spherical coordinate system, then this is centered at the origin. If I, from the origin, if I draw up, this is point P. If I draw a line like this is called radius. Okay, this is on xy plane. Xy plane means flat plane. Hit xy plane means flat plane. This is xy plane. On top of it, again, this is xy plane. On top of it, again, this is xy plane. If there is a sphere, and on xy plane, if I cut it, it will form a circle. If I if I if a sphere is centered at the origin, and if I cut at the middle of the sphere, it will form the circle. Okay, if I go up, then if I go up and cut it again, the circle will be smaller. If I go at the tip of the sphere and cut it, there won't be any circle. So radius of the circle, if I cut horizontally the sphere, it will be maximum at the middle, and that radius will be the radius of the sphere. Okay, anyway, we saw that this is the radius vector. Okay, if this is the radius vector, then this is the theta angle on xy plane. On the flat plane, if I move a line like this, it forms theta angle. Whereas on the vertical plane, vertical ZXY axis plane, this is ZX plane, this is ZY plane, this is Z any XY axis plane. If I move the radius in along the Z any XY axis plane with the vertical, it makes angle called phi. It makes angle called phi. This arc, what we see the arc, this arc is contributed by this phi angle, this arc. This arc and this radius is perpendicular to each other. Similarly, if I see in the horizontal axis this arc that is contributed by angle theta, this arc and vertical arc that is contributed by phi, three things are there in a spherical coordinate system: theta, phi, and the arc. So phi arc and theta arc, they are at perpendicular to each other, whereas phi arc is perpendicular to the radius, and radius is again, if I take xy plane, this is the radius is again perpendicular to the theta arc. These kind of explanations certainly it is not available in any of the book. Anyway, in that fashion, if I talk, then all three length, one is radius length, one is vertical arc, one is horizontal arc, all three are perpendicular to each other. If three things are perpendicular to each other, we can say it is a coordinate system. So in coordinate system, we typically say r, theta, phi is the spherical coordinate system. But actually it is r, an arc that is made by theta, an arc made by phi. These three are actually makes the coordinate system. Anyway, we are in phase of calculating surface area with the spherical coordinate system. If I take the point P, if I take this sphere and it is centered at the origin, means if this is the flat xy plane, then it will go at the middle, and center of this will coincide the blue color here mark, that is the origin. Half of the sphere is above, half of the sphere is below. Okay, if that is the scenario, then consider that I take any point P here, any point P here, and at the P, this is something that we was. This is not there in any of the book. Summation, through the repeated summation, we are calculating the surface area in pure spherical coordinate system. This is any point P. From P, take a line like this and draw vertically and come back to the P. Any angle you can take. Any angle you can take. From here to here, flat, and here to this side. Any angle you take. Okay, make sure that you come back to the P. This is phi angle. With the vertical, I'm changing the phi and making so along the variation of phi. If we remember, we took two circles earlier. One was keeping y as constant. We took a circle. This is priceless discussion. Keeping the y-axis, we made a circle earlier in xz plane. Keeping the x-axis constant, we made a circle in yz plane. Make sense? Now keeping the theta is this. Keeping the theta constant, okay, that is that if this is the P here, this is point P here, P can be in xz plane, P can be in yz plane. I am talking about P that is anywhere. It is if this is point P and I chop here horizontally, then it forms a circle. On this circle, P is anywhere, anywhere. From x-axis, it makes angle theta. This is 90-degree y-axis. Any theta angle with the x-axis, anywhere P is there, keep theta constant. So what what I'm saying is, now this is x-axis, keep theta constant. Keep theta constant here. And then rotate in making phi variable, keeping theta constant. Makes sense? It forms a circle. This is the vertical circle where phi is varying, theta is constant. Now make another circle, keeping now this is the phi. This is the point P I have taken, where it forms theta angle with the x-axis. Makes sense? There is a radius like this, and it makes phi angle with the vertical. and then if I drop it on xy plane, it makes theta angle with the x-axis. Okay. Now in this fashion, now I am drawing this, now keeping the theta constant. If I place it on xy plane, this is angle theta. This is angle theta here, angle theta here. Okay, keeping the theta constant, I rotate in a fashion keeping the theta constant, only phi should vary. Now this is one thing. Second thing is I rotate in a fashion that keeping phi constant. This is the vertical angle phi. Now I'm keeping the vertical angle constant and then I'm rotating the theta. There are two circles I'll get now. One circle is vertical circle where theta is constant. One circle is the horizontal circle where phi is constant. Okay, now let's chop. Okay, now this is the vertical circle. Now vertical circle where theta is constant. Let's chop it into n different parts because phi is varying. What is length of the ith part? Now let's chop this into n different parts. What is the length of the jth part? Okay, these two lengths at any point P. Make sense? Search any book. This is not available there. So if this is point P and then I move along horizontally and this is point P, I move vertically. Point P is there. At point P, if I see the horizontal circle, then that belongs to jth section if I cut horizontal circle into n different parts. If I take vertical circle and I cut into n different parts, this point P exists in ith section. This is what I am saying. Radius is constant. Okay. What about if radius also changing with the function? This much I am not taking like this. So if this is the vertical circle, I chop into n different parts, then what is the ith section length at point P? And this is a horizontal circle. Uh, I'm sorry, this is a horizontal circle. I chop into n different parts, the jth section at same point P. What is its length? Now they are vertical to each other. This circle and this circle, they are vertical to each other. If I multiply more or less, I'll get the area subsection on the kind of ith jth part. What are you doing? If I have a sphere, I chop the sphere in vertical manner. I chop the sphere in a vertical manner. I'm sorry, I chop the sphere in the phi manner. There is a phi manner. I chop the sphere in theta manner. In theta manner. I chop the sphere in phi manner. I'll get many sections here. If I chop one in n part and I chop another in n part, I get n square number of area on this surface. On this surface, I have n square number of a small area here. I'm talking about the I comma jth area where the vertical circle I chopped into n part and that is ith part, and horizontal circle I chopped into n part, the jth part. At point P, I'm talking about the area that is I comma jth area. What is this area? Length of this ith section and length of this jth section, if I multiply, I get a pseudo area. Okay, what is the vertical ith section area? What is vertical ith section length? Simple. Radius into, consider this vert with vert consider with the vertical, this is the ith section. This is the ith section from here to center. From here to center, if I draw a line, then it makes an angle called delta phi I because phi is variable. In horizontal, if I cut into n part and then if I take jth part, if I take the jth part, then for the jth part, if I draw the line to the center, then this angle is delta theta jth part. Now I have the arc length for the ith part in vertical and arc length for the jth part in the horizontal. The vertical part, if I say arc length, then it is r into delta phi I, and here it is r into delta theta I. Make sense? Okay. Now what is the surface area? One multiply by another multiply. What is the first one multiply? First one arc length. First one is r into delta phi I. That is the arc length. What is the another length? R into delta theta j. If I multiply, I get the area because I consider they are perpendicular to each other. Now I get the ith jth section area. Okay, now we will proceed more now. Now consider that this is a sphere centered at the origin and this is xy plane hitting it. If P was here and I make a cut, then the radius of the circle is the radius of the sphere. But if I have P is here and if I make a cut, then the circle will be small. It will not be like circle. Like circle is decreasing in the size. But in vertical, if I make anywhere cut, the circle will be full cut. So the first, if I talk about at point P, I have radius R, that is the full phase radius. Then R delta phi I is the first arc. But if I say a horizontal arc length, then it won't be R because this circle radius is smaller than the radius of the sphere. How much it is? That is question mark. Okay, if I say like this, then there is a radius like this and it makes a phi angle from the vertical. If this is radius like this, it makes phi angle with the vertical. R sine phi will fall on x axis. Makes sense? Now from here, this is R and this is phi. R sine phi will fall on x axis. Now length of this is R sine phi. Okay, this r sine phi, this length is the circle at this point. At this point, we have a horizontal circle. What is the radius of that circle? That is r sine phi. That is the radius of that circle. So r sine phi delta theta j is the jth section arc. Makes sense? Now, understandable, right? If this is xy plane, then if I cut horizontally, then this circle has a radius of r, that is the radius of the sphere. But if I go little bit up and make a cut, then circle will be smaller and its radius will be, if that point from the center radius is r, then r sine phi. Or if this is the phi angle and this is the radius, and this is r and this is phi, then r sine phi is this one, r cos phi is the height. Okay, so this radius is r sine phi. This radius is r sine phi and delta theta j I have moved. Now we have the area vector at point P is r delta phi I into r sine phi, whatever phi it has made, delta theta j. Okay, I believe it makes sense. What are the vectors now? If I see the vertical arc, then vector is phi vector because it is moving in that fashion. If I see the horizontal arc, then it is moving in theta vector. Theta vector is the theta arc vector. And this is the perpendicular, this is the phi vector. And this is the radius vector. Okay, if I talk in vector, then it comes as r delta phi. Now summation I equal to 1 to n, summation because we have chopped into n area on the surface. Summation I equal to 1 to n, summation j equal to 1 to n. Okay, now the multiplication of two items. Now if I talk in vector now, then it will come as magnitude. Makes sense? Because it is a vector now. So earlier we were talking about magnitude only, r delta phi I and r sine phi delta theta j. Summation I equal to 1 to n, summation j equal to 1 to n, r delta phi I into r sine phi delta theta j. This is the area of the ith jth section. If I sum it, I'll get the net area. If I take in vector form, then it will come as magnitude. Magnitude r delta phi I phi vector into r sine phi delta theta I theta unit vector, phi unit vector theta. Multiplication of two vectors is not possible. I have to take cross product or dot product. So we'll take cross product. We are talking about the area. Now it came as r delta theta I theta unit delta phi I r delta phi I phi unit vector cross product with r sine phi delta theta j theta unit vector cross product, its magnitude. This is the ith section area. If I sum it for the all section, we get the full surface area. I equal to 1 to n, j equal to 1 to n. Magnitude r delta phi I, phi unit vector. Cross product r sine phi delta theta j, j unit vector, theta unit vector. If I do cross product of phi unit vector with theta unit vector, it will give r unit vector as per the coordinate system. I cross j is k unit vector. Similarly, if it is a phi cross theta, this is not available in any of the book. Phi cross theta unit vector will be r unit vector. Now it will transform as r, and here r square sine phi delta phi I delta theta j, r unit vector magnitude. R unit vector magnitude will go away. There is 1. So at the end we have summation I equal to 1 to n, but area vector will be along the r unit vector. Everywhere r unit vector. Anyway, we are calculating the area. Summation of I equal to 1 to n, j equal to 1 to n, magnitude r square sine phi delta phi I delta theta j. Now, what the way we did in xy plane, we will do the same here also. R square sine phi and then delta phi theta, delta phi theta. Now we will take summation k equal to 1 to n square and function over theta and phi, theta phi plane axis, that is r square sine phi, function over theta phi, and then delta theta phi of the kth section, function over theta phi axis in kth section, delta theta phi of the kth section. This, if I transform into two dimensions, this is theta phi axis and this is function over theta phi axis. Then if I chop into n square, this is the area of one subsection, that is summation k equal to 1 to n square, and then function over theta phi plane axis magnitude, and then delta theta phi of the kth section. Okay, if I add all the subsection, it gives the full integration. This is a fit case to transform into integration. Integration of theta phi plane axis from minimum to maximum, function over theta phi magnitude delta theta phi. So it will convert into integration, function over theta phi d theta phi. Since theta and phi are perpendicular to each other, orthogonal, it will be converted into d theta d phi, and this will be converted into r square phi, sine phi. Will it give the surface area? Certainly. Okay, if I see theta phi plane, their limit, they are not dependent upon each other. Phi is varying like this and theta is varying like this. In this fashion, we can take numerical limit. Theta is 0 to 2 pi, phi is 0 to pi. R square sine phi d theta d phi. If r square is constant for the surface, r square outside. Sine phi integration is cos phi. 0 to pi, 2 I can keep outside, 2r square d theta integration, that will be theta 0 to 2 pi. 4 pi r square is the area of surface area of a sphere. We'll proceed on this. Probably one more session or two more session it will take. We will settle down in other concept in the surface. This is multivariable repeated summation to the double integration. But whatever we do, if we are converting repeated summation into integration, we have to bring it to single dimension. Then only we can proceed on the double integration triple integration. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.